Compare and contrast facilitated diffusion and carrier-mediated diffusion. To start out with, both of these are going to be examples of diffusion, and so diffusion is the movement of materials down their concentration gradient. Now, when we're taking a look at this in relationship to the cell membrane, normally the cell membrane is going to be impermeable to the materials that we're looking at moving across the membrane. So impermeable meaning that they're not able to pass directly through our phospholipid bilayer here, primarily because of the hydrophobic characteristics, the nonpolar covalent bonds of these fatty acid tails are going to establish an environment in which water-soluble molecules and charged molecules and ions are unlikely to be able to pass through the membrane completely on their own. So in the process of simple facilitated diffusion, facilitated is a term that indicates that we are assisting the process in some way. So facilitated diffusion is going to be movement of materials down their concentration gradient with assistance. And that assistance is going to be coming from proteins. And so the simplest example here, we've got a transmembrane protein. And so we've got a protein embedded within the membrane. It's along the extracellular side. It's along the cytoplasmic intracellular side, and then as part of the kind of structure for this transmembrane protein, we're going to end up with this hydrophilic pore that is going through the middle of this structure. Now, with a hydrophilic pore, we're basically forming this hydrophilic tunnel through the membrane. And so these red molecules, these red dots over here, are going to be things that have maybe ions, they may be charged molecules, they're going to be examples of polar molecules that can't move through the membrane on their own, but they're going to be able to pass through this hydrophilic pore. As a process of diffusion, they're going to be moving from their area of high concentration to their area of low concentration. And so when this basically ion channel or tunnel through the membrane is open, it's going to allow for things to move through it. Now, the things that move through it may be based on size, based on charge, a whole variety of other parameters that are involved. So it can be still specific and selective for the materials that it moves through. Normally, these ion channels are going to have a gate, which means that they can be in a closed position if the gate is closed, or an open position. In the open position, the gate is going to be open, allowing for materials to pass directly through this hydrophilic pore and go from the extracellular side to the cytoplasmic side. Or if we're looking at the concentration gradient being reversed, it would be able to, again, go in the opposite direction, again, following its concentration gradient. A more complicated form of facilitated diffusion is using these carrier molecules. So instead of a simple tunnel in which these materials are kind of moving on their own through this, we're going to use this carrier molecule. Again, another example of a transmembrane protein. It completely spans across the membrane, and it's going to have two configurations. It's basically going to have two shapes. In one of the configurations or one of the shapes, it's going to be open to the extracellular side of the membrane. In the other configuration or other shape, it's going to be open to the cytoplasmic or the inside of the cell. As we move down, or materials move down their concentration gradient, they're going to interact with that protein. And so we've got the red dot coming in here, interacting with the protein. The action of binding of our red dot, the molecule to move down its concentration gradient with our carrier protein, is going to result in a shift in the shape. It's going to go from opening towards the outside of the cell to opening of the inside of the cell. Once we're in that open to the inside of the configuration, again, part of that shape of that protein is going to change, making it more likely for that red dot, the molecule that needs to move down its concentration gradient, to be released into the cytoplasm of the cell. Now, this could go in the opposite direction as well, but we're basically going to be shifting between open to the outside or open to the inside. And in doing so, it's going to be the driving force of materials moving down their concentration gradient, binding with the protein, then is going to trigger the change between the open in the outside and open in the inside position. So again, in both of these cases, we are assisting in the process of diffusion, so materials that would normally not pass through the hydrophobic barrier within our phospholipid bilayer, so the fatty acid tails in a nonpolar environment, is going to block the passage of charged ions and hydrophilic molecules with this hydrophilic pore, or by basically, kind of hiding these materials as they're passing through the membrane, we're allowing them to pass through this barrier in a controlled and specific selective way.